On a polynomial function, the points on the graph where the graph changes from increasing to decreasing or vice versa are called turning points. Each turning point will yield a local maximum or a local minimum. We can predict the maximum number of turning points by looking at the degree of the polynomial. If f is a polynomial function of degree n, then the graph of f could have at most n minus 1 turning points. And the converse is also true, which is that if f has n minus 1 turning points, then the degree of that polynomial function must be at least n. In order to make sense of this, let's look at an example. Given the polynomial function, the first thing that we're asked to do is to find its degree. Remember, the degree is determined by the highest power of x once this polynomial is completely multiplied out. Multiplying it out could be tedious, but we can tell what that highest power is going to be by adding together the powers on the factors that contain x's. And so in this case, the degree is going to be 1 plus 2 plus 1, which is 4. The power function that this polynomial resembles at infinitely large values of x is going to be determined by the leading term. We know that that leading term is going to have a power of 4, and as well it's going to be multiplied by this constant multiple of 7. That leading term is going to be 7x to the 4th power, and then the rest of the terms would need to be calculated from there. But the power function that gives us the end behavior comes from just the leading term. While it's not asked in this question, that leading term does tell us that the end behavior of the polynomial function is going to be up to the left and up to the right, because this is a 4th degree polynomial function with a positive leading coefficient. Now the maximum number of turning points for a polynomial of degree n is going to be n minus 1. So we don't know much about this graph yet, but we do know that for this 4th degree polynomial function, it can at most have 3 places at which it changes from being increasing to decreasing or vice versa. Now just to say that slightly differently by looking at a graph, let's consider 2 different 4th degree polynomials. One which is just x to the 4th, and the other that has 4 unique linear factors. The first polynomial, x to the 4th, only has 1 turning point. But the second polynomial function, which is also a 4th degree polynomial, has 4 zeros and therefore 4 x-intercepts. We have an x-intercept at -2, -1, +1, and +2. We also have a y-intercept at 0, 4. The end behavior is up, up because the leading coefficient is positive, and the graph crosses at each of these x-intercepts. And we can see that it has 1, 2, 3 turns. This is the maximum possible turns on a 4th degree polynomial, and that occurs when we have 4 unique factors and 4 zeros. And of course we can see it is possible to have fewer turns than that, but this is the case where we would get the maximum number of turns.